For example number 8, we're going to use Descartes' rule of signs. We're going to use Descartes' rule of signs to determine the possible numbers of positive and negative real zeros for f of x, which is equal to negative x to the fourth minus 3x cubed plus 6x squared minus 4x minus 12. So let's take a look at, first, begin by determining the number of sign changes. We can see that we have a sign change which goes from negative 3 to positive 6. So there's one sign change. And then it goes from positive to negative, which means there's another sign change. So we can see here that there are two sign changes. So there are two sign changes, which means there are either 2 or 0 positive real roots. Okay. Next, we want to examine f of negative x to determine the number of negative real roots. So we're going to replace x now to be negative x first to figure out how many negative real roots that there are. So now that we put in negative x to the fourth power, we get negative x to the fourth minus 3 times negative x cubed, which becomes plus 3x cubed. This becomes 6 times negative x squared, which becomes a positive, so it's positive 6x squared. And negative times a negative makes that a positive 4x, and then minus 12. So now what we're going to do is we're going to go ahead and see what are the changes. Well, it goes from here is negative to positive, and then from here it goes from positive to negative. So we can see that those are our sign changes. So again, from negative to positive here, and then from positive to negative here. So again, there are two sign changes, so there are either 2 or 0 negative real roots. So that tells us that there's a possibility of 4 roots. Okay, now we can put this in a chart. So it's possible that we have 2 positive real zeros or 2 negative real zeros with 0 complex zeros, which gives us 4 total. Another scenario is that we have 2 positive real zeros, 0 negative real zeros, and 2 complex zeros, which is going to give us 4 total zeros. Another possibility is that we have 0 positive real zeros, 2 negative real zeros, and 2 complex zeros, which would give us 4 total zeros. Or the last scenario is we can have 0 positive, 0 negative real zeros, but 4 complex zeros, which will give us a total of 4. Now, if we graph this actual function, we can confirm the number of positive and negative real roots by examining the graph of this function. So in here, we can see from the graph that the function has 0 positive real roots and 2 negative real roots. So you can see here on the right axis, we don't have any positive roots. But over here, we have a negative root here and a negative root here. So that tells us we have 0 positive real roots, 2 negative real roots, which means we'd have 2 complex zeros.